we will start our problem with a rectangle. Then from the top left corner of the rectangle, we will pull a line all the way to the midpoint of the right side of the rectangle. Then from this midpoint we will pull another line connecting the bottom midpoint of the side of the rectangle, and finally we will connect this point back to our original point, and therefore we will form this really nice triangle with the area of 3. The question is, can we somehow use this triangle to calculate the area of the entire rectangle? This beautiful problem was sent to me by one of my youngest subscribers, Annie. Her dad made this problem and she was asking me to make a video about it. So here you go, Annie. I hope you enjoy it and thank you so much for your beautiful email. It really touched me a lot. So I hope all of you guys will enjoy this problem as well. It is not really difficult and I think you can figure it out on your own. But nevertheless, you can pause the video right now and then come back and check my solutions. Alright, so let's solve this problem. So first of all, I'm going to offer 2 different methods to solve this problem. And the first method will be dividing our rectangle. So first let's simplify our image a little bit and let's pull a vertical line which divides our rectangle into 2 identical smaller rectangles. Now let's bring back the left side of our triangle. As you can see, this side represents the diagonal of the left rectangle, so it would divide our rectangle on the left into 2 identical areas. So this means that our shaded blue area must be the half of the area of the entire rectangle. So this area represents 1/4 of the area of the entire rectangle. Alright, so let's clear the image and now let's divide our rectangle horizontally into 2 identical rectangles, the top and the bottom one. Now let's bring back the upper side of our inscribed triangle. Of course, you can see that again this is the diagonal of the top rectangle, so it will divide this upper rectangle into 2 identical areas, and this upper area will represent the half of the entire rectangle, or again it would be 1/4 of the entire rectangle. Finally, let's clear our image and let's divide our rectangle into 4 identical smaller rectangles. If we do this, we will bring back the right side of our inscribed triangle. And again, we have the situation that our rectangle on the bottom right is divided into 2 identical pieces. So the area of the smallest piece will be 1/2 of 1/4 of the entire rectangle, or it will be 1/8 of the entire rectangle. Alright, let's go back to the original sketch. Now you can see that we can actually write the area of the entire rectangle as the sum of the areas of 3, a/4, a/4, and a/8. Now we can just multiply everything by 8 to get rid of the fractions, we can simplify the common terms and put all our unknown terms on the left. And therefore we will get that 3a equals 24, which means that the area of the entire rectangle equals 8, and this is our solution. Alright, so now let me show you the second method, and this method will be really similar to the first one, and we're just going to use the areas for this method. So, in order to do it, we only need 2 things. The first thing is the area of the rectangle, so the area of the rectangle will be base times height, and we need to know that the area of any triangle equals to 1/2 of the product of the base and the height. Now we're going to use those formulas, but first let's have a look at our sketch on the left. Let's label the length of our rectangle as A and the height as B. And this means that the bottom side will be divided into two identical segments of a over 2, and the right side will be divided into two identical segments of b over 2. Now let's clear our image a little bit, and let's have a look at the right-angled triangle on the bottom right. Let's label this triangle as A1. So, using the formula for the area of the triangle, we know that the area of this triangle equals to the 1/2 of the product of its base and the height. In our case, the base is a over 2 and the height is b over 2. So this means that the area of this triangle equals a times b over 8. Now let's do the same thing for the triangle on the top, and let's label its area as A2. This time we have the base of A and the height of b over 2, so we're just going to implement this into formula for the area, and we will get that A2 equals a times b over 4. Finally, we will do the same thing for the triangle on the left. We're going to label its area as A3, and you can notice that this triangle has the base of a over 2 and the height of b, so the area will be 1/2 times a over 2 times b, which really nicely simplifies to ab over 4. Alright, so now let's have a look at the area of the entire rectangle. This area will be equal to the sum of the areas A1, A2, A3, and the area of the triangle in the middle with the area of 3. And now we're just going to substitute the values for those areas which we got earlier, and we will get the following equation. Now let's clear our image, and remember, we're looking for the area of the entire rectangle, and this area can also be written as the product of the base and the height of the entire rectangle, or a times b. Now we can just substitute the value of AB for the value of our area into our first equation, and we will get the following. From here, the process is basically the same as in method number 1. We're first going to multiply everything by 8 to get rid of the fraction. We're going to group the common terms, and we will get that 3a equals 24, which means that the area of the entire rectangle equals 8, and again we have our solution. Well, I really hope you guys enjoyed this problem. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this. If you found another way to solve this problem, please write it down in the comment section below. And if you know a person who enjoys problems like this, please share this video with them. And until next time, see you guys and take care.